Welcome back to our fourth lesson in our prerequisite chapter for precalculus. This lesson focuses on lines in the plane, and we will be learning and reviewing the various forms of equations for lines in the coordinate plane. So let's get started. All right, we have your learning targets on the top that you're welcome to read, and I'm going to jump in with the definition of the slope of a line, which should be familiar to you from Algebra 2, and the slope of any non-vertical line is given by the change in y over the change in x, which is the vertical change over horizontal change. And the way to think of the slope of a line is always a rate of change. Vertical lines have undefined or no slope, and they have the form of the equation x equal to and then a constant. Horizontal lines have a zero slope, and their equations are y equal a number. Parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes. So the opposite sign, and then they're inverted. All of that should be review, nothing new there. The point-slope form of a linear equation is y minus y1 equals m times x minus x1, where the slope is m and the point is x1, y1. Slope-intercept form is y equals mx plus b. Again, the slope is m, the y-intercept is that letter b. And the general or standard form of a linear equation is ax plus by plus c equals 0. And a, b, and c are integers. And remember, an integer is any number that's a positive or a negative whole number. So here's our first example. Suppose we have a line and its slope is negative 2/3 and it goes through this point, negative 4, 3. Write the equation of the line in point-slope form. Well, point-slope form is the y minus y1, so it looks like this. Y minus 3 equals m, which is negative 2/3, times x minus a minus 4. So minus a minus gives us a plus, and that is in point-slope form. Part B says write your answer from part A so that y is a function of x. Basically, that means solve it for y. So we need to add 3 to both sides, and that gives us that equation. And lastly, we want to graph the line on the grid. Well, I also already put in the 1 point here. That's negative 4, 3. And then using our slope, we could put in another one where we go down 2 and right 3. And I could put another one in there as well, down 2 and right 3. And then let's go ahead and graph that line and see what that looks like. Just need to get my arrows on both ends. There we go. And let's do this one in red. So there you have it. That is the line whose equation is y minus 3 equals negative 2/3 x plus 4. Example 2, find the slope-intercept form of the line that passes through the point negative 2, 4 and has a slope of 7/16. Well, the slope-intercept form, we're going to start with the point-slope form, which is here, but then we need to solve it for y to get it into slope-intercept form. So remember, on this page, all of our answers will be in slope-intercept form, y equals mx plus b. So let's go ahead and solve this. We need to distribute the 7/16, and then we need to add the 4. Well, I wrote 4 as 32/8 because when we distribute the 7/16 through the parentheses, multiplying by 2 here, we get 7/8, and now we can add our constants together, and that gives us y equals 7/16 x plus 39/8. That is now in slope-intercept form. So what if we have a line that passes through this point and then this point here? This is a new equation now. Well, first of all, we need to figure out what that slope is going to be. And so using those 2 points, we get a slope of 3/5. And then from there, we can go ahead and start with our point-slope form. Y minus 7 equals 3/5 x minus 3. I just used this point. You could use this point as well. Okay, but in order to make sure that it contains that point, we're going to go ahead and use that one. And then to get it in slope-intercept form, we need to solve it for y. So again, adding the 7 to the right-hand side, that's the 35/5. And distributing the 3/5 through the parentheses, combining our like terms, gives us y equals 3/5 x plus 26/5. Lots of fractions in here. Find the general form of the line passing through 1, 3 and having the following characteristics. So we want a slope of negative 2/3, and it goes through this point, and this time we are looking for the general form, okay, or standard form, ax plus by plus c equals 0. So we're going to start out with y minus 3 equals negative 2/3 x minus 1. That's our point slope form. And then in order to get this in standard form, we can't have any fractions. Remember, those coefficients must be integers. So I'm going to go ahead and multiply that entire equation by 3, which gives us 3y minus 9 equals negative 2 times x minus 1. So now to put it in standard form, we need to distribute the 2 through the parentheses and then just get everything on the left-hand side, and we get 2x plus 3y minus 7 equals 0. Part B, perpendicular to this line, passing through that point. So again, we need to figure out what the slope is going to be. And the slope of this line, we can solve it for y. So we have 5x equals 2y, dividing by 2, we get 5/2 x. So this is like y equals mx plus b, where m is 5/2. So now we know that our slope is 5/2, which means the perpendicular to this line would be the opposite reciprocal, or negative 2/5. So now we have the slope of the line, and it's going to go through that point. So we're going to go ahead and start with y minus 3 equals negative 2/5 x minus 1, using m as our slope of negative 2/5 and using this point. And then to get it in standard form, we want to multiply by 5, okay, so that we get rid of our fractions. So here we go, 5 times the whole thing, and we get 5y minus 15 is negative 2x plus 2. The 5 here cancels, and the 5 over here is going to be distributed through the parentheses. Okay, so now we just need to work on that and get it in standard form, bringing our x term over to the left and combining our constants. We get 2x plus 5y minus 17 equals 0. Part C, parallel to the y-axis, going through the point 1, 3. Well, the y-axis is a vertical line, and it has the form x equals 0. So x equal a number, right? And this is actually the y-axis. That's the equation for the y-axis. So to be parallel to that and go through this point, we only need to know what the x coordinate is. So the equation of our line is x equals 1. Finding the depreciation of real estate. Camelot Apartments purchased a $50,000 building, and it depreciates $2,000 per year over a 25-year period. Write a linear equation giving the value y of the building in terms of the years x after the purchase. Well, we're starting with 50,000, and then we're going to subtract off 2,000 times the number of years x, okay, and that will equal y. So our equation is y equals 50,000 minus 2,000x. That's a linear equation. In how many years will the value of the building be 24,500? So we're looking for the number of years, which is our x variable. So we're going to solve for x. And this number, 24,500, we're going to plug in for y. So let's go ahead and do that. And so now combining our like terms, we get 2,000x is equal to 25,500. Dividing by 2,000, we get x equals 12.75, which is 12 years and 9 months. For our last slide, we're going to look at finding a linear model for Americans' personal income based on a data table. And it says Americans' personal income in trillions of dollars is given in this data table right here. Write a linear equation for Americans' income y in terms of the year x using these 2 points, using our first 2 data points right here. So those first 2 data points, we need to find the slope so that we can write the line. So remember, it's the rise over the run. It's the change in y over the change in x, and y is the income and x is the years. Okay, time is the independent variable. So that works out to be 0.3, so that's our slope. Then what we need to do is pick one of those terms, or one of those points, one of those two data points, and plug that into our point slope formula, or excuse me, our slope intercept. So we're just going to choose the first one. So here is our slope intercept formula, but we need to know the y-intercept. So if I just plug in 8.9 for the y value and 2002 for the x value, solving that for b, we end up with minus 591.7. So then we can put that in back into the equation up here for b, and we get y equals 0.3x minus 591.7. So that is the equation of our line, and this is in slope-intercept form. So I'm just going to highlight that so it's easy for us to find. Part B says, use the equation in A to estimate Americans' income in 2005. Well, remember the income is the y variable and the years are the x variable, right? So if we want to estimate the income, that's the y variable. We're trying to find that, okay? So we're going to basically plug in 2005 for x and calculate what y would be. And that turns out to be $9.8 trillion. Part C says use that same equation to predict Americans' income in 2010. Very similar to Part B, except you're using 2010 instead of 2005, giving us $11.3 trillion. Part D, superimpose a graph of the linear equation in a scatter plot, on a scatter plot of the data. So what you would want to do in your calculator is plug this equation in, put this data in the table on your on your graphing calculator, and then draw a scatter plot. So these dots right here are the scatter plot. If you don't know how to do that on your calculator, be sure to see me in class, and I can show you how to do this. And then here is the equation of the line. So you can see it's an approximation. This is definitely an approximation, but as we get further and further out in time here, this is looking like more of an exponential or a quadratic than it is a linear model. So it's not really a good approximation. And that's going to do it for this lesson. See you next time.